This is example 2, check understanding 2 on page 34. Okay, we're solving another absolute value equation, and we know that we're going to have to take a step to remove the absolute value symbols before we can start doing operations to solve this. However, before we do that, we need to isolate the absolute value, meaning we need to make sure that this absolute value of 3x minus 1 is alone on one side of the equal sign before we break down the absolute value. So there's two things on this side of the equal sign for us to get rid of. We need to get rid of this 2, and we need to get rid of this plus 5. Right? We really should take care of this plus 5 first. Right? So we subtract 5. Two times 3x minus 1 absolute value equals 28. Okay, we still haven't isolated. Divide both sides by 2, right? Never try to use distributive property. Absolute value of 3x minus 1 equals 14. Okay, now we've isolated the absolute value. We can break it down like we did in the prior example. Right? This thing will be true if 3x minus 1 equals 14, or if 3x minus 1 equals negative 14. Because even if this equals negative 14, when we take the absolute value of it, it'll be positive 14. So solve both of those. Right? Add 1. (3x) equals 15. 3x equals negative 13. Divide by 3. X equals 5. Oops, sorry about that. Or x equals negative 13 thirds. Again, you can check those answers by plugging them back in the original equation, plug in for x, and then see if you get the same thing on both sides of the equal sign. All right, make sure that you understand the example 2, which is above this, on page 34.